Okay, let's go. So, transformation questions. You might notice when I go through these, there's already some writing on some of the pages because I've already tried to record this lesson once and it didn't work. So, rather than waste paper and print it again, I'm just going through it as it is. What I wanted to do in this lesson is, because we've looked at reflections, we've looked at rotations, I wanted to try and bring those together a little bit and get us to practice doing both at the same time, or rather choosing, are we doing a reflection, are we doing a rotation, looking at shapes and saying, is this a reflection or is it a rotation? That's sometimes something that pupils can find difficult. There are actually 4 types of transformations, so reflections and rotations are both counted as transformations. We're not looking at the other 2 at the moment, but I am going to mention them here just so that we're aware of them. We're not going to practice doing them, but I want us to be able to spot when they happen. So if something isn't a reflection or a rotation, we can say, well, I know what it is instead. So the first 2 types of transformations that we're looking at are translations and reflections. And we already looked at reflections, and I said when we do a reflection, we can think of it as flipping the shape. So for instance, if my hand gets reflected across the middle of this piece of paper, it flips, it goes back to front. So my thumb has started off on the right hand side. When it's reflected, it ends up on the left hand side. Okay, so it's back to front, but my hand stayed the same shape, it stayed the same size. Okay, it just went back to front. And whenever we do a reflection, we have a mirror line that we use. Okay, and as we practiced in our lessons earlier on this week, that's usually the equation of a line. So it might be x equals 4, y equals 3, y equals x, or y equals minus x. It can actually be any straight line, but it's usually a horizontal, vertical, or vertical line, or a diagonal line through the origin. So y equals x or y equals minus x. Which, if you did the extra task that I mentioned in our lesson earlier this week, you might already have practiced. A translation, we can think of as something sliding across the page. So it doesn't flip, it doesn't go back to front, it doesn't turn, it just moves. So it might move left or right, it might move up or down, it might move a mixture of both. But it is just moving across the page. So the informal word that I use for that is sliding. Okay, again, we can't put that in exams. If we're answering a mathematical question on a type of transformation, we want to be using these words, translations, reflections. We can't say flip or slide, but that might be how intuitively we think about them. Okay, the other 2 types of transformations are rotations and enlargements. So rotation, we've already looked at. Rotations are given as degrees about a point. So we can think of that informally as turning. So we've got sliding, flipping, turning. They stay the same shape, they stay the same size, but obviously don't stay the same orientation because they turn around. So if I'm rotating something, we can see actually it doesn't flip, it doesn't go back to front. So if I rotate my hand here, okay, you can see my thumb is on the right hand side of my hand. When I rotate it, it's still on the right hand side of my hand. So I might need to turn my head to see that properly. But we can see if I turn the paper, or if I can't turn the paper, if I turn my head, it looks the same way around. It's facing the same, things are facing the same way in a rotation. In a reflection, they're not, they've gone back to front. Okay, we're going to come back to that later to decide are things reflections or rotations. Okay, the final transformation, but the other one apart from translations that we're not going to look at here, is an enlargement. So we can think of that like a scaling. It's when we make things bigger or make them smaller, and they do stay the same shape. Okay, but they don't stay the same size, obviously being made bigger or smaller. So that's like if you think of something being just being enlarged, being made bigger. Maybe like Ant-Man in the Ant-Man movies, when he gets made bigger, he gets enlarged. He's still the same shape. He doesn't have a tiny head and the rest of his body is huge. All the parts of his body are in the same proportion. So his arms and legs look normal size relative to the rest of his body. but they've all been made bigger or been made smaller, depending on what he's doing. Okay, so what I want to go through now is just look at some examples of some different types of transformation. So I've already written the transformations on here. I'm going to try and explain how I know what those transformations are. I'm going to then pull up another sheet with some other examples. Maybe at that point you might want to pause the video before I do each one and see if you can figure out what it is. And then there's some other sheets that I've put on Google Classroom for you to try. So this first one, we can see from here to here. So we're always going in these questions from A to B. How has the rabbit changed? What's the movement? Is he been rotated? Has it been turned? No. Is it back to front? No, they're both facing to the right. So it's not a rotation. It's not a reflection. It's a translation. He's just moved. So moved across, moved to the right, moved down. That's a translation. And I'm not going to write down how we describe that translation. That's for another lesson at another point. Here we've got a rotation. Okay, how can I tell it's a rotation? Well, if I turn the paper round, so this rabbit is facing to the left. If I turn it around, so the other rabbit's facing sort of the feet like pointing upwards. He's facing to the left as well. They're both facing to the left. That means they're not back to front, so it's not a reflection. Okay, they've just turned round. You could see when I turned it round that they look the same as one another. So that's how we know that is a rotation. And so I've put a rotation. I know it's 180 degrees because it's half a turn. So I'd have to turn the paper. If I move this over here, I'd have to turn the paper a half turn round for it to get in the same point. And the reason I know it's about this point 1, 1 is because if I put my pen there and turn the paper about there, the rabbits end up in the same place. Now that's quite easy to see if we have tracing paper. I can draw my shape on the tracing paper, put my pen on there, turn the tracing paper around, and the rabbit would end up above that one. I can't do that if I don't have tracing paper, obviously, which I'm expecting not many of us have. So what I'm looking at doing instead is the same idea we looked at in the rotation lesson of looking where the shape is. So here, shape A, we've got this part of the rabbit is 1 square to the right. So if I pick this as the center of rotation, say well, if we've turned 180 degrees round, this is that would then go 1 square to the left, which is where that point ends up. Okay, I could do that at another point as well. So if I look at this point, that's 1 square to the right, 1 square down. If we imagine that arm there turning 180 degrees, it'd go 1 square to the left, 1 square up, and we can see it ends up, so 1 square up, it ends up in the same place on the rabbit. So that gives us an indication that that point is the right center of rotation. How did I know it was 1, 1 before I started checking it? It's something that we can pick up and we can guess. There are methods that you can use to determine exactly what the center of rotation is. I think if you can practice guessing, sort of having an educated guess, trying it out, seeing if it works, the more you do that, the easier that process will become until eventually you'll be able to pick out the exact right point more or less straight away. Okay, this one again is a rotation. How do I know it's a rotation? Well, it can't be a translation because they're not the same way around. It can't be a reflection because this rabbit is facing to the left, and if I turn that round, so is rabbit B. So it must be a rotation, and they're the same size, so it's not an enlargement. And then it's just picking out where the center of rotation is. So you can see I've looked at a couple of points here. So I picked out this point 1, 1 as the center of rotation. This point in the rabbit was 1 square to the right, 2 squares up. If I rotated a quarter turn, so 90 degrees in this direction, anti-clockwise, it would, instead of 1 square to the right, 1 square up, instead of 2 squares up, 2 squares to the left, would go to the same place on the rabbit. So I can be quite confident that is the right center of rotation. Okay, the final one on this page Here, this rabbit is facing to the left. If I turn that round, that rabbit is facing to the right. It can't be a rotation because they're not facing the same way. So instead, I'm going to go for reflection. They're not the same way around, so it's not a translation. They're the same size, so it's not an enlargement. So it's a reflection. And then all I need to do is pick out 2 points, 2 sort of corresponding points. So this is the back of the rabbit on both of them and the top of the back of the rabbit. And I can draw lines between those two and work out what's halfway in between those lines. That's where the mirror line needs to be, because we remember when we did reflections, we said they're the same distance away from each point. The mirror line's the same distance away from the reflected image as it is from the original image. Okay, let's have a look at this one as well. This is the only one I didn't do before, but let's have a look at it now while we're here. This rabbit, rabbit A, is facing to the left. Rabbit B is facing to the right. It's not a rotation. They're facing different ways. Okay, can't be a translation because they're not the same way up. So we're going to go for a reflection. So I'll pick out 2 points. Let's pick out this point at the front of the ear. I was going to pick out that point. The reason I didn't pick out that point is because it's in the middle of a square, so it makes it a little bit harder to judge to make sure I draw the lines accurately. So I can go between those 2 points. That's 1, 2, 3, 4 diagonal squares. So my mirror line should go through there. That's 2 diagonal squares in between. Let's pick out another point. So let's pick out the top of the back of the rabbit there. And I can join those up. That's 1, 2, 3, 4, 5 diagonal squares. So my mirror line should go through 2.5 diagonal squares in between. And then I could do that for more points if I wanted to, but I think I can probably just draw my mirror line between those two. If I wanted to be absolutely sure, of course I'd do another point. So we would say that is a reflection, and that is in the line. So if you did the extra lesson, you might know this. If you didn't, probably not sure. That's the line y equals minus x. Okay, 3 more to look at here. This is, again, facing to the right, facing to the left. They've gone back to front, so it must be a reflection. I picked out these 2 points. Halfway in between is here. Same for those two. So I get a line going through there. Vertical line. It goes through the x-axis at -1, so it's a reflection in the line x equals -1. Every point on that line has the x-coordinate -1. Here we've got a rabbit, well, let's turn the right way up, a rabbit facing to the left. Another rabbit facing to the left isn't a reflection because they're not back to front, so it must be a rotation. Okay, and again, it's just picking out where the center of rotation is, what the turn is. So this is my initial rabbit, rabbit A. I said 90 degrees because it looks like it's a quarter turn to me. It's not sort of going upside down, so it's not 180. So it's 90 degrees. It's moving in that direction, so that is anti-clockwise. So it's 90 degrees anti-clockwise, and then I pick out where I think the center of rotation is and check that. Okay, this last one. It looks to me immediately like a reflection. If we're not sure about that, we look at, are they the same way around? So that's to the right. That rabbit is to the left, so they're back to front, so it must be, they're not the same way around, they're facing different ways, it can't be a rotation, so back to front, so it must be a reflection. And then I can pick out 2 points, halfway in between is here. Okay, if I do the same there, there's 1, 2, 3, 4, 5, 6 squares in between, 3 squares in between is there. That gives me this line going across as the mirror line. So it's a reflection in the line y equals 0. So it crosses the y-axis at 0. All the y-coordinates there are 0. Or I can say it's a reflection in the x-axis. They're the same thing. Okay, if, again, we're not as sure about those being reflections, remember, said that reflections look a lot more obvious if you make the mirror line vertical. So do that if you need to. Okay. So this is like one of the sheets that I've put up for your homework, or your sort of individual exercises. I'm not going to look at all of these, but we're going to have a look at a few. So it's asking, how do you get from the start of trapezium S to each of the others? So I'm looking, how do I get from this to each other shape? Let's have a look at one first of all. Okay, so starting off at this shape to one here. Okay, throughout all of these, when I pick out a shape, what I would do is I'd pause the video, have a think about it yourself, see if you can spot at least what type of transformation it is, and then play the video again to see if you're right. Okay, I think if I turn this way, I can see very easily that that's been flipped, right? It's back to front, so I can pick 2 points, got that halfway in between, the same with these 2 points. So I get this mirror line. Okay, so I know it's a reflection. So this is for shape 1, and it's in the line. Let's see, if I carry on that line, it would cross the y-axis at -2. So in the line, y equals -2. Okay, and that's number 1 done. Number 2 is a translation, so I'm not going to do that one. Number 3, ooh, that looks a little bit trickier. So let's have a look at number 3, see where we think that would go. Okay, if you've had a go at that, see if well, first of all, I might want to try and think, is it a rotation? So if I turn that round, if I imagine this shape turning round, can I get it to look like that one? So have in your head what that shape looks like. If I turn it round, it doesn't look like that shape, does it? No point is it looking like the other shape started up. So I don't think it's a rotation, I think it's a reflection. But where's my mirror line going to go? It's not entirely obvious to me. Okay, now if I think it's a reflection, I have sort of got a cheaty way of finding that, which is just start plotting those points like I did before. So I know this is the point at the end of this straight line. So if I go between those, that is where my mirror line would go through. If I do the same to these 2 points, so 1, 2, 3, 4, so my mirror line would go through there. So my mirror line is going to be this line here. So for number 3, it's a reflection in the line y equals x. Now I referred to that as a sort of a cheaty method a minute ago, and which is maybe a bit unfair because there's absolutely nothing wrong with it. It's actually a very accurate way of working that out. The reason I refer to it as a cheaty method is because I don't have any idea what it is before I start doing it. I'm just sort of following the procedure. Actually, what I might want to do, if I think the shape's a reflection, is turn it to try and figure out where my mirror line would be vertical. So if I had turned the shape like that, I might have been able to see, now it looks like it's been flipped. It looks like it's been flipped across a line down here, and I would have known that my mirror line was that diagonal line. Okay, 4 again is a translation, so we're not going to have a look at that. I'm just going to do one more on this page. And that one more that we're going to do is going to be number 8. So maybe if you want to pause the video, have a look, see if you can spot where number 8 goes. Okay, so if I think about which way around that is this back to front? It doesn't look like it to me, because actually this longer side is now at the bottom. It looks like it might have been turned. If I turn this round, does this shape end up looking like this one does now? Yes, it does. So I'm quite confident that for number 8, we have a rotation. Okay, think about how far I turned that. So 90 degrees didn't look the same. 180 degrees it did. So it was a half turn, so it was 180 degrees. Because it's 180 degrees, I don't need to say whether it's clockwise or anti-clockwise, give the same result. I just now need to get the center of rotation. Okay, and this is where we might be looking at a bit of trial and error. Okay, I'm going to go for the right spot straight away because I can see where that is. That's just a lot of practice that I've had at doing this. So that's the coordinate 0, -1. So it's about 0, -1. How can I be confident that it's 0, -1? Let's pick a point. Let's pick that point, which has that as its corresponding point. That is 3 squares to the right. If I turn that line around 180 degrees, it would instead go 3 squares to the left. It would go to that point, and I could do that for the other points on there as well. Okay, so this is the sheet that I've asked you to have a look at, have a go at. I'm not asking you to do all of the shapes. If you can just name whether they're reflections or rotations, maybe even translations, that would be excellent. I have put some information on which shapes I think you should look at on the Google Classroom post, so do have a look at that before you try it. And don't worry if you find it hard, it is not the easiest task that I've set you. And then this is the other sheet that I've added and asked you to have a go at. I just want to do a couple of examples from here just to make sure that it's clear, because the instructions aren't massively obvious on this. So if we have a look at a couple of these, any shapes that have this M, it's telling you what the mirror line is. That's not standard mathematical notation, but it's saying it wants you to reflect them. So if it says M, it's asking for a reflection in the line that it says afterwards. So this is asking you to reflect this square in the line PQ. So we'd be taking this square, saying that's 1.5 away. So half, 1.5 would go to there. This is 1, 2.5. So half, 1.5, 2.5 would go to there. And we'd carry on drawing that shape. I'm not going to do it because I don't want to give you the answers. Similarly here, this is asking you to do a rotation. So where that has a degrees, it's asking you to do a rotation. This is a rotation 180 degrees about A. So you'd find the point A, which is this point here. And we want to rotate this shape 180 degrees about A. We do that exactly the same way we did for rotations in our other lesson. So this is 1 square to the left, 3 squares up. If I turn that arm around 180 degrees, instead of going 1 square to the left, I'd go 1 square to the right. Instead of going 3 squares up, I'd go 1, 2, 3 squares down. That point would go there. I'd do the same for the other 2 points, join those up and see what you end up with. Okay, hopefully that's been useful. A lot to take in there. By far the most difficult lesson out of the 2 weeks we've done on this topic. So do let me know if you have any questions, anything you're not sure about, and have fun trying the questions.